Hey, what's up? Welcome to One Little Coder. In this stable diffusion tutorial, we're going to learn how to create your own stable diffusion model. That is fine-tuning stable diffusion model with DreamBooth. And specifically, we're going to look at fine-tuning stable diffusion version 2.0, which means the latest stable diffusion model is at your service for you to fine-tune it for your own image or own style. Before I begin this video, I would like to say that my experiment of fine-tuning failed terribly, primarily because of a lot of reasons, but that may not be applicable for you, and that is exactly why I decided to make this video even though my output does not look good. So if you feel that my output does not look good, my apologies for that. But this method and the steps that we are going to follow they are actually robust and can help you fine-tune your own style or images using Stable Diffusion 2.0 DreamBooth. First, let me show you what I have done and then how it looks like. So my idea was to create a model that can create avatar style images. For example, if I go give a prompt saying mermaid in, this is my token, avatar cam is my token, but imagine that is avatar. So mermaid in an avatar style. So I wanted actually to create images that are in Avatar, the movie Avatar, James Cameron's movie Avatar style. And that is exactly what I attempted to do, but it does not do its job properly. For example, if I just say one image and if I say car in Avatar cam style, which means ideally I want a car in that style to be created, but that doesn't happen because the number of images that I had was less. Second, the number of training that I did was not enough. Third, there are a couple of parameters that I had to play. And fourth, sometimes the styling does not work very well, but rather the profile picture or a display picture or AI avatars, those things work very well. But overall, once again, like I said, I would like to show you how this can be done for your own use case. But this is the output that I've got. So let's start with first how this all started. So there is a new blog post that came out, like I think yesterday, from Kaliyuga, who is part of the Stability AI team, but this is not an official tutorial from Stability AI. The tutorial says training a DreamBooth model using Stable Diffusion v2.0. And I was very particular that whenever I wanted to make a Stable Diffusion v2.0 fine-tuning DreamBooth tutorial, I wanted to make it only on Google Colab, because primarily a lot of tutorials that, if you know our channel, I always try to make using free resources or resources that are easily available for anybody to use. I understand that this may not be stable for everybody, but again, my objective here with this channel as well is that anybody and everybody should be able to do whatever that I am doing it. Sometimes we go for paid solutions, but most of the times we try it with free resources. So I was very particular about that fact. The reason why I am highlighting this is, if you have got a GPU access, then you can use the notebook from the last bin. I think if you're in the stable diffusion world, you would know the last bin. So you can use the last bin if you have got a powerful GPU. But if you have got a free Colab tier, you don't have Colab Pro, you don't have any other GPU access, if you have got just free Colab, this tutorial will exactly work for you without any problem. So thanks to Kaliyuga for putting out this tutorial, this detailed blog post, and also the associated Google Colab notebook, which I am using for this particular tutorial. Now, before we get started with the Google Colab tutorial, the first thing that you need to do is you need to prepare your images. You need training images, especially like if you're doing an AI avatar, you need images that are different poses of yourself. And you need to crop those images into 512 by 512 if you're doing a 512 model. And that is something that I'm going to show you how you can do it. Quite simple. You don't need a lot of knowledge, but this is how I have done it. So what I basically did is I went to YouTube and I went to the avatar trailer, and I played the trailer, and for every instance I took a snapshot of it and then I started using it. So this is how I collected my training data. So after I collected about 30 images, then, like as suggested by Kaliyuga, you can go to this website, which I'll link in the YouTube description, boomi.net, and you can click browse from your computer and select all the images. Right now I've named it like this. This is how you should ideally name it, but if not as well, that's fine, because we'll get that output image. So the token name, space, open bracket, 1, close bracket, and then you go until 20 or 30, whatever number of images that you have got. Open all the images. So for us to crop it into 512 by 512, you can select the option auto detect image focal point. That will algorithmically try to detect the image focal point, but there could be some instances where it could not match, so you can move this accordingly. So you can move, 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 move. It depends upon again what you are trying to build. In my case, I wanted avatar style, so I wanted to focus on their faces, which turned out to be a terrible idea, because when I actually trained the model, I particularly mentioned that there are no human faces associated with that. That's a different topic altogether. Now, after you have mentioned the size 512 by 512, after you have cropped, like set the cropping, then the next thing that you can do is you can go and then click rename it. It's quite important. If you just want original image name, just leave it, or if you want a name that you're comfortable with, you can give, or you can just leave it empty, and then you can just simply say the starting number should be 1, and then download it as zip, save as a zip file, and then that will download all the zip files. It will download one compressed file, and when you uncompress them, you're going to get all these images, beautifully cropped 512 by 512 images, which is what you're going to use for your DreamBooth fine-tuning of Stable Diffusion 2.0. So this is the first important step. The first step, as very rightly mentioned in Kaliyuga's blog post, you need to gather the data set. You have different ways of doing it manually, like I did. You can take screenshots and then do it, or you can take your phone's camera and then take pictures of yourself, whatever way that you want to do it. Collect data. That's the first step. And the second step is you need to process the data set, which means you need 512 by 512 images that are very well cut, correctly named. The aspect ratio is 1.1. If you are going to use your smartphone to take pictures, you can do it already by selecting an aspect ratio of 1:1 while you are going to take the picture. You can make that change on your camera, but if you're going to use a picture that use somewhere like I used from a YouTube trailer, then you can use the tool that I just showed you, which is bulk image resizing made easy. That tool is available, and I'll link the tool in the YouTube description. So now you have downloaded the zip, unzipped it. Now everything is good for you to go. This Google Colab notebook will be linked in the YouTube description. So what you have to do is, once you get the Google Colab link, then click connect, which will connect to the GPU. Once you get connected to the GPU, the first thing that you need to do is check the GPU, which in this case I've got a Tesla T4 machine with 16 gig RAM. So you can understand what is the machine that you have got, how much is the memory that you have got. Why is this critical? Later on, when we are going to specify the model parameters or model training parameters, this information will come handy, and it is quite important for us to decide what kind of parameters we can use depending upon the machine we have got. The next thing is install all the requirements, which in this case is very simple. You need diffusers, Triton, accelerate. These are quite important for you to do the training. But again, the script is borrowed from Shivam Srirao, who's one of the first Stable Diffusion DreamBooth Google Colab notebook creator. So this is basically building on top of their work, and some scripts are borrowed from that. I have specifically installed the diffusers from Hugging Face because this has got Xformers at this point, so which makes things faster. So just run this. That will install all the required libraries. The next thing is, you don't have to, you can still skip this. If you're going to do for Stable Diffusion version 2.0, you can skip this step. If you're going to do this for Stable Diffusion version 1.5, then you might have to log in and authenticate with Hugging Face account. If you're going to do it for Stable Diffusion 2.0, you can skip this. Xformers, even though I was told that it is pre-installed as part of the diffusers, I still went ahead and installed from this pre-compiled wheel. The next thing is, you need to give the stick mark. Once you give the stick mark, it is going to ask you to mount, or it is going to ask you to give authorization for your Google Drive. So which means this Google Colab notebook is going to use your Google Drive as a storage option, and that is why you are able to see my Google Drive options here. So save to drive, the moment you click it, it is going to ask you to give authentication. Do it, then you're good. So the next thing is, it's going to select the model name. This is by default present there if you don't edit anything. The model that we want to use is Stability AI Stable Diffusion version 2.0. That's what we have mentioned here. And where do you want the model to be downloaded? That is how or where you want this model data to be stored on your Google Drive. And that's what I've given, because I'm using a token AVTR cam, like Avatar Cameroon. That's what I thought. So I have gone with the same naming convention. Once this is done, it is going to say your model weights are going to be stored in this particular location, which you can always come back and refer in case if you forget. The next thing is we are going to start the training. Now we have got the training data. We have got the basic settings, but before even, like at this point until now, we have still not uploaded our training data, which means the images. But critical information for us is to understand what kind of parameters that we should use. These are the parameters that you've got. Do you want FP16 or no? What is a train batch size? Gradient accumulation steps, gradient checkpointing, use 8-bit Adam. What now? If for this particular parameters, if you set them, if you change their value, what is the GB of VRAM usage and what is the speed of iteration? And there is always going to be a trade-off. And this is particularly tested on Tesla T4. So I went ahead with the first setting because when I iterated and tried a lot of other options, I got out of memory CUDA, out of memory issue. But you can try your luck. So if you want to be on safer side, I would strongly recommend you to go with this particular setting, which in this case is FP16. FP16 is true, train batch size is 1, gradient accumulation steps is 1, gradient checkpointing is true, use 8-bit Adam is equal to true. And you can see some information like gradient checkpointing flag is enabled by default because that reduces the VRAM usage by 9.2 GB. Like that you've got 16 gig, so you want to reduce it because PyTorch also has a separate hold on the memory in itself. So like these are things that you have to play with, and then that will help you understand things better. So the next thing is another important aspect is if you remove train text encoder, the memory usage is going to be less. It is going to do things faster, but it is going to severely degrade your output quality. So if you want to just experiment, if the output quality doesn't matter, you can disable or remove train text encoder in the future step, but it is not recommended at all. Just remember that in your mind. The next place is where we are going to specify our style or concept. We call it concept here. So what is the concept that we have got? So we have got two kinds of prompts. One is the instance prompt. Second is the class prompt. So the instance is what we are exactly trying to do. What am I trying to do here? I am trying to do an avatar style image, which means the class, the kind of class that my instance belongs to is a style, and the instance here is avatar com. For example, if you are going to do it for your own image, let's say you are going to create it for your own image. Like for example, I want to call it one little coder, and I can call it a person or a man. So this would be my class prompt, and this would be my instance prompt. And you can again play with these things. Like for example, sometimes if you want it to be invoked by saying photo of one little coder man, you can keep it like this, and then you can say photo of man. You can try different aspects here, but the idea here is your instance is specifically for what you're trying to do here, and your class is something that under which your instance belongs to. Then the same way you can give the directory. These things do not matter a lot because this is basically the directory that is created inside your Google Drive for you to organize the files. And the good thing here is that you can design, you can specify multiple concepts, which I did not do because because I've focused on only one thing, I did not do it. Another thing is, before you create these prompts, it is a good idea for you to test these prompts using Stable Diffusion v2. So go to my other tutorial, invoke your own Stable Diffusion Gradio UI, run these prompts, and then see what kind of images are generated. If the images that are generated at a CFG of 7 and 50 steps do not look great, if for this prompt, if the images that are generated do not look great, then you need to use a different class prompt that is going to specify what kind of image that you're going to create. So in my case, This is one of the drawback that I did not try my prompt on Stable Diffusion v2 before actually training, because I was so excited to train. So that's another mistake. Please do not make it. First, before you give the prompt here, like for example, if you want to say a photo of a man, then go to Stable Diffusion v2, put this prompt, and then see how it works for a CFG of 7 and 50 steps, and then come back and add the prompt here. Because if that image is not crispy or correct, which means your prompt that you're trying to use is not very well defined in the base model, which means even if you fine tune it, it's not going to look good. So that's something for you to keep in mind. Once you run that, the next step is where you need to upload the image, run the cell. Like every time you have to run this cell, this play icon, run the cell, then it's going to open choose files, choose all the files at one time, and then it is going to upload. This is one way to do it. The other way is you can go here, select the particular select the folder. Like for example, you can select avatar cam, and inside that you can upload the image. You can either do this or you can do this. If you do it using the sidebar, it's going to be slightly faster than this, but if you don't bother about it, then you can do whatever you want. Now at this point, completely ignore this, you don't need it. So now at this point, you're going to set the parameters. This is another important aspect from whatever we learned before, whether we need FP16, whether we need like for example, whether we need what did I say, train batch size 1 or 2, do you want to use train text encoder or not? So all these things you have to specify here. So this is the main place where everything is going to happen. So I'm not going to get into every single detail, but few important information for you to note. The output directory and the model name comes from the parameter that you have defined before. Seed value will help you in reproducing it. The resolution, in this case 512, but if you happen to do for 768 by 768 or the new 768 Stable Diffusion model, then specify the right resolution here. If you don't want a lot of memory to be occupied, then you can use train text encoder or remove it. One of the most important thing again that can define image quality is the learning rate. I actually reduced learning rate a lot. By default, I got this learning rate when Kaliyuga posted this Google Colab notebook, but because I was working on time, because I wanted to make a tutorial where I've already spent hours, I decided to change the learning rate. So that is something that you need to play with. Try with one learning rate, doesn't work fine. After like 1.5 hours, for me it took 1.5 hours for 6,000 step. That's another thing. So after 1.5 hours, if it doesn't work, try with a different learning rate. Learning rate at this point has a really critical key important thing. Like if you are familiar with deep learning, you know that learning rate helps convergence. Sometimes if you select a very small learning rate, then convergence might not happen. When you select a very large, like a bigger value of learning rate, again it can things can go south. So learning rate is important. This is something that you need to play with. The next thing that I also did to reduce time is I reduced the number of classes of images. This was by default ideally 50. This is something that I reduced, something for you to keep in mind. The next thing is how many steps that you want to. The larger the step, the better your model is. But again, you have to see whether the model is overfitting, which we'll see later on. But do that. The next thing is save interval. So at which interval for every number of steps, at what point you want the model to be saved in your Google Drive. And again, don't go with something like 500 or 1000. It depends, because if you have got lesser storage on Google Drive, if you store every 1000, then your Google Drive is going to run out of space, and then whatever it is running here will not work properly, because now it doesn't have space to store the model. So what I have done here is I wanted maximum 6,000 step. So I said every 3,000 step store the model, which means 2 models are going to get stored. But even then, like I had to delete one more model before the final step. So just be very clear about these things, which will help you not to stop something in the middle and then come back. Another thing that I've noticed with this Google Colab notebook is, if by any chance, if you start the process, like by any chance, after starting the process, if you have to stop and if you restart it, it is going to throw you CUDA out of memory error, which means you have to redo everything again. You have to go to runtime, disconnect and delete runtime, and then connect it and then do everything again. So to avoid that, it is very important for you to do this without any issue. because otherwise you have to redo everything that we did before, and that's actually painful and boring. Now once you set this ready, then it is going to start running. Okay, the final one is a sample prompt. The sample prompt is nothing but like when you have this model saved, it can save sample prompts. Like while the model is getting saved, it can create something and then it can store it. So this is basically the sample prompt. This will also help you understand how good the model is doing. So give a good sample prompt. So that is this. So the next thing is, once you run this, you're going to see model gets downloaded, and model, the training process starts. And you can also see while the training process is happening, you can see the loss going down. That's another important thing. See how the loss is going down, see whether it is going to overfit, play with the learning rate. These things are not fixed. I don't think anybody has a rule of thumb at this point, or probably some great genius has got it, but I don't think a lot of people have got this rule of thumb here. So play with these values, change different values that will help you generate a very good model. So the next thing is, after this is done, at this point you might have a directory where you would have like this, 0, 3000, 6000. You would have all these things. I've already deleted 3000, so you would have all these values inside it except model.ckpt. You would have everything else inside it, which is like basically what creates a stable diffusion: a scheduler, text encoder, tokenizer unit, VAE, and so on. So now what you have to do is, if you have these models, that's well and good, but like this is just to display the image, the sample image. But the point is, these models can be uploaded on Hugging Face Model Hub, but it might not work on UIs like automatic 1111, where they expect a ckpt file. So you need a ckpt file there. So this step, this run conversion, this step will convert the model weights from diffusers weights to the ckpt version. So which means you're going to get a beautiful model.ckpt, which also you can upload it to Hugging Face Model Hub, but also at the same time you can add it to automatic 1111 or any other UI where you have got a place to upload a ckpt file. A lot of UI or a lot of software, stable diffusion softwares these days come with ability for you to upload the ckpt file. So this is another important thing for you to pay attention to: converting your weights from diffusers to ckpt to use in web UIs like automatic 1111. Okay, now that everything is done, let's start with inference. We can start with inference by run this Gradio application. Once you run this Gradio application, you're going to get a URL like this. Once you go there, you can now start defining what you want. Ever that cam style, so, boy. And then you can add negative prompts as well. If you're not familiar with negative prompts, I've got a separate video about negative prompts, which I'll strongly recommend you to check it out, because at least for stable diffusion version 2.2, it looks like negative prompts play a critical role. So you can see how the image looks. The image doesn't look great. So you can now, what you can try to do is, you can try to change the guidance and then see how it looks. If it still doesn't look good, now you can try to add negative prompts. Like for example, right now I've got deformed, cartoonish, 3D, ugly, duplicate. You can add more negative prompts and then you can see how it looks. So right now you can see my model has been overfitting. My training images are very less. The training process did not happen properly, so it keeps on using the same images. But what I observed, one interesting thing is, it may not be even useful for anybody. The moment I add fractal as a negative prompt, the kind of images that I got looked really fractalish, and I was quite surprised by the kind of images that I got when I said fractal. So you can see, let me reduce the steps and then click generate, and it's going to generate images. For me it looked like fractal. So if you actually train well, these things matter a lot. Like you would actually see really good quality images, but for me right now it looks like a disaster. That's why I'm trying to find some kind of happiness from what has been created for me. So I started seeing images. So like now you can see some different images. But yeah, that's how images are generated. Now the next thing is, you can go back, stop this. You can download this model you can download this model, go to Hugging Face, you can go click new model, and after you click new model, so for example, bad avatar SD fine tune, and or I should say incomplete, and select the license. I think this has to be OpenTrail or OpenTrail plus plus, and then click public. And once you click create the model, you can go to file version and then add a file and upload the file, and then you can now upload the ckpt sorry upload the ckpt file that you downloaded from here. So right now I'm going to stop it, but that is how you can also upload this model. Or if you want to get it, then you can upload all these files to Hugging Face Model Hub, which means anybody using diffusers will be able to use your fine-tuned model if you upload all this content to the Hugging Face Model Hub, like if you want to share it, if you want everybody and anybody to use it. But the overall idea here is, first start with data preparation, second go on to do data processing, third do basic setup, the next thing is understand your computation environment, then set the right parameters, and then finally start generating. For me it took about 1.5 hours for 6,000 steps. It might be totally different for you depending upon number of images, the learning rate, and everything, like the GPU that you get, everything else that you have got. Like I said, I have particularly restrained, or like I was bound by using only the free Tier of Google Colab notebook, and that is how I ended up using Kali Yuga's DreamBooth Google Colab notebook. But if you have the liberty of using a better GPU, feel free to explore other options as well. Or even this, you can use higher number of steps, or like different learning rates, or very shorter learning rate that will help you do better stable diffusion fine tuning. So play with these things that will help you in creating a much better model than what I have done. What I've done is basically a joke. So my apologies once again that the results do not look good, but the process is going to be perfect. Like the people say, the journey here is the destination for me, and you should also try it out, and that will help you in creating your first, or if you're used to creating your own fine-tuned stable diffusion version 2.0 model using DreamBooth, thanks to Kali Yuga's notebook that helped me do this entire thing. This Google Colab notebook, the blog post, the link of Birme, whatever it is, will be linked in the YouTube description. Any questions, let me know in the comment section. Otherwise, happy stable diffusion.